Welcome back to Arxflix. Today, we're diving into a fascinating paper titled Dropout Q Functions for Doubly Efficient Reinforcement Learning. This research introduces a novel method named DroQ, which aims to enhance both sample and computational efficiency in reinforcement learning. Randomized Ensemble Double Q Learning, or REDQ, has recently achieved state-of-the-art sample efficiency in continuous action reinforcement learning benchmarks. The trade-off? It uses a large ensemble of Q functions, making it computationally intensive compared to methods like soft actor critic or SAC. Here's a snapshot of the dropout Q function implementation. This modification is critical to the DroQ approach that we'll break down in more detail. To make REDQ more computationally efficient, the authors propose DroQ. DroQ simplifies REDQ by using a small ensemble of dropout Q functions instead of a large one. These Q functions are enhanced with dropout and layer normalization, making DroQ both CPU and memory efficient while maintaining high sample efficiency. DroQ leverages the power of dropout to inject model uncertainty into Q functions. Unlike REDQ, which needs a large ensemble of Q functions, DroQ employs a smaller ensemble, effectively reducing computational costs. Let's touch upon the primary contributions of DroQ. Firstly, easier implementation. Just a few lines of code for dropout and layer normalization. Secondly, first successful employment of dropout in high UTD ratio settings. Thirdly, engineering insights for effective dropout usage in RL. In this study, the authors focus on maximum entropy RL, where an agent maximizes expected return with an added entropy bonus to encourage exploration. Here, pi is the policy, mathcal is entropy, and alpha is the temperature parameter balancing exploration and exploitation. The algorithm of DroQ mirrors that of REDQ, but with key modifications. Dropout is introduced into the Q functions, effectively replacing the need for large ensembles. Here's how the target value is computed in DroQ. This smaller ensemble of dropout Q function significantly reduces the computational overhead while maintaining accuracy. The authors carried out extensive experiments to evaluate DroQ's performance. They compared DroQ with REDQ, SAC, and another baseline method called DUVEN across several MUJOC benchmark environments. DroQ runs more than twice as fast as REDQ, while requiring significantly less memory. This makes it especially practical for real-world applications where computational resources are limited. For instance, in Hopper v2, DroQ required about 948 milliseconds per overall loop, compared to REDQ's 2,328 milliseconds. In terms of parameters, DroQ uses about 1/5 the number of REDQ. In summary, DroQ offers a doubly efficient reinforcement learning method, combining sample and computational efficiency. It achieves this through a smaller ensemble of dropout Q functions, making it a versatile and practical choice for modern RL applications. That wraps up our overview of dropout Q functions for doubly efficient reinforcement learning. Check out the paper for more detailed insights and experimental data. Don't forget to like, share, and subscribe for more deep dives into the latest research papers. Thanks for watching Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.